Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over a few problem sets and exercises for for loops, just for a bit more practice so that you can see how for loops will work differently from while loops in many different scenarios. Let's get right into the exercises. Okay, so as with the previous exercise videos, I have a few kind of problem set demos ready to go. All of these kind of work the same way. In this case, for the for loop video though, I've actually used the exact same questions as the while loop on purpose, just so that we can see exactly the differences between the while loop and the for loops side by side. So if you haven't seen the while loop one, I encourage you to see that video just so you can get practice with both of them, because really seeing them side by side really kind of helps cement the idea of which loop works well in what scenario. So that said, let's go for the warm-up first. So for the warm-up, we have a question that says create a for loop that prints out the numbers from 5 to 10 inclusive. So with a for loop construct, this is actually quite a lot easier because everything's kind of forced on us, quote unquote. So let's see what I mean by that. So in this case, we're going to start a number at 5. So we're going to say let's just say num equal 5. We're going to say while the number is less than or equal to 10, because we want to go all the way up to and including 10. We don't want to skip 10, and we want to go up by 1 every single time. So we want the number to go up by 1. So we can just do num plus plus. What you can sometimes see is num plus equals 1, just like this. Whichever is kind of easier for you to kind of wrap your mind around. Usually for 1 though, plus plus is the operator that most people end up using. I'll leave it as plus equals 1 just for kind of a change of scenery. So we can do a console.log of this number every single loop. So unlike the while loop, just as a recap, we can't like really accidentally forget the number to increase here. You can see that we're kind of forced almost to have it in the for loop construct. That's what I meant by that. Technically, this is optional, so we don't actually have to have it here, which we'll see in a future example. However, it's much less likely that you'll forget it with a for loop. And usually if you need some kind of counting or something like that, a for loop is a bit of an easier loop to go with. So let's see what this looks like and make sure we got this right. So if I run node and then problem set warm up in this case, you can see that I get 5, 6, 7, 8, 9, 10, which is exactly the answer that we were looking for. Perfect. Let's go to the first exercise. So for this one, we want to print out all the even numbers between 10 and 40, and then we want to switch it to do the same for all the odd numbers as well. So give yourself a chance to do this, and when you're ready, you can come back and unpause the video. Okay, so for even numbers and odd numbers, the key here is the modulus, just as a recap if you haven't seen that one before. But let's start the for loop construct here. We're going to do all the numbers between 10 and 40. Let's assume inclusive. So we'll say, I'll use I just to keep things simple here. And I'll say while I is less than or equal to 40, and we want to go up by 1 each time because we don't want to accidentally miss any numbers. Technically speaking, we could cheat here and go up by 2 each time and just not have to do any check inside of this loop. So if you came up with that solution, good on you. And then for the odd numbers, we could kind of start at an odd number and go up by 2 each time as well. However, I'll show you the slightly longer way just so you can see how that works. So for even numbers, if the number that we're looking at, modulus with 2 is exactly equal to 0, then we're in an even case. Okay, so in this case, we want to print it out. So we want to console log out the number. And then if it's not even, which means if we don't enter this conditional, we can just not do anything. So again, like the previous example in the warm-up, we can't like accidentally really forget this I++. I think I did that in the while loop exercise video. So it's a bit easier to kind of wrap your mind around because you're kind of forced almost to have this all stuff going on near the initializer, the check, as well as the updater. So the key here is we're doing a check only if the number is divisible by 2, which means it's even, are we going to log it out? So let's see what this looks like. If I clear this out and I run node and problem set 1, we see that we can get all the numbers between 10 and 40 inclusive, and we're only getting the even numbers. To get the odd numbers, we can just switch this. So if we say if it's equal to 1, the modulus between these two, between I and 2, that means that the remainder between the number divided by 2 is 1. So that's the only other option when we're modulusing by 2, and that'll give us the odd numbers. So if I run that, you'll see that I indeed get the odd numbers for that one. Perfect. Let's go to the second exercise. So this is a bit tricky with a for loop. And again, I kept these kind of in parallel just to kind of see the differences and strengths, pros and cons of the while loops and the for loops if you get a chance to do both. But for this one, we want to create a variable called logged_in that starts off as false. Then we want to create a for loop that loops while logged in is false. So we can probably do this in the initializer. Each loop, we want to print out incorrect login credentials. After 3 loops, we want to change logged in to be true. And then after the loop ends, we want to print out successfully logged in. Okay, so this is going to be a little bit funkier with a for loop, but let's see how we can kind of make this work. So we want to create a variable called logged in that starts off as false. We could do this before the for loop, but since a for loop has a initializer construct kind of built into the structure, we can just do it right in that area. So we can do let logged in equal to false to start. Okay, and then we want to loop while logged in is false. So while logged in is equal to false. And then we're going to have some updater here, right? I can't really do this because I'm going to comment out the last thing, but we need some updater here, or do we? I don't actually know yet. Let's think about this. I'm going to just finish off this loop, and then we have the rest of it. So just to clean this up a little bit, whenever you see something like this where you're checking directly against a Boolean value, this is the same thing as kind of asking while we're not logged in, right? Like conceptually, logged in being true is we're logged in being false is while we're not logged in. So a nicer way to actually refactor this so that's a little bit easier to read and save some space is instead of checking for exact equality with false, we can just say while we're not logged in, just like that. So this is going to take false. It's going to flip it using the not operator, and we're going to get true, and then we're going to enter the loop as long as logged in is false. Okay. Now, let's just kind of think about this as we go. So I've skipped the updater for now, but we're saying each loop we want to print out incorrect login credentials. So I'm going to say console log, and then I'm just going to copy this, incorrect login credentials. Great, so that's step 3. After 3 loops, we want to change logged in to be true. Okay, so if we think about this deeply, that means that we need to keep track of how many times we're kind of looping, right? Like some kind of counter, like we would with like an I variable. So again, we could do this before the for loop, but I'll go ahead and create a counter for us right in here as a second initializer. And I'll just say I, which is going to start at, let's say, 0. I always mess myself up by starting at 0, but I'm so used to it at this point after many years of programming that I just always start at 0. And I, for those of you that haven't seen this before, I usually is used in computer science a lot. I guess most people would say it's short for kind of index, which we'll see when we get to arrays. So if we have a number starting at 0, do we need this to be updated every single time? Well, yeah, because we want to make sure that every single time we do one loop that the updater actually increases I in this case by 1. So actually we can do I++ right here because we want to go I from 0 to 1, 1 to 2, and then 2 to 3. Then once we're at 3, then we know that we can actually change logged in to be true. Okay. So let's do that check. So inside of this loop now, we can actually check for I, right? We're going to say if I is equal to 3, I think I got this wrong, but we'll see in a second, which means if we're on our third loop, then we want to change logged in to be true. So we're going to say logged in is equal to true now, right? So this only will run when I is 3. And changing logged into true, which means that when we come back up here into the conditional check for the for loop, this is going to say not true, which is false. And we're going to skip to the end of the for loop. All right, which is number 4 here, which is after the loop is done, print out successfully logged in. So I'm just going to console log that out right here. Console.log successfully logged in. Okay, I'm pretty sure I got my numbers mixed up here. I always do that, but let's see how this goes. So if I run node, problem set 2, So we get incorrect login credentials. Yeah, I was off by 1 4 times, and then we get successfully logged in. So in this case, to run the correct amount of times, we're going to run this till 2, and then there we have it. Okay, so I would say that definitely a little bit funkier to look at this code. If you're not used to kind of how you can have multiple initializers, how you can do a check here that's different than kind of this updater here, right? There's a lot of kind of different things happening compactly in this one line here. So as you get started, this might be quite complicated compared to a while loop. Maybe not the best candidate, right? Maybe it makes sense to use a while loop in this case instead of a for loop. Arguably, you could use a for loop once you get more used to it, because maybe this reads better. Sometimes it's a personal preference thing. Sometimes there really is a better option. That's one or the other. And in some cases where you need things like an infinite loop, it can probably be better just to have a while loop that's more explicit. Okay, let's go to the final problem set here together. So this one took a bit of time with the while loops because there was a lot of new concepts we had to learn, like the continue keyword. But let's go through this one at a time, and I'll give you a chance to try it out before we do it together. So we want to create a for loop that runs from 1 to 100. Let's assume that's inclusive. Every 10 loops, we want to print out checkpoint and then the loop number. So just like this, just like we see over here, checkpoint 10, 20, 30, 40, etc. However, on loop 50, we want to print out only halfway there, which means that we don't want to print out checkpoint 50. We want to print out halfway there instead on the 50th loop. We do want to still continue looping though all the way up to 100, and similarly for the 100th loop, step 4, we want to print out you made it, which is a different statement than what we're printing out for 50, but it's also not just checkpoint 100. And after the loop is finally complete at the end of the loop, outside of the loop construct, we can actually print all done. Okay, so give that a shot and then we'll go through it together really quick. Okay, so I hope that you were able to get pretty far with that. Most likely you got stuck at some points, especially if you haven't had a chance to look at the previous videos on how for loops work or the while loop exercise video. There are some tricky parts of this, so let's go through it together. Don't worry if you weren't able to get these. These are meant to be challenging on purpose. So we want to create a for loop that runs from 1 to 100. So we know how to do that. We'll say let I equal 1. While I is less than or equal to 100, and then we want to go up by, let's just say 1 every single time. Okay, just like that. Perfect. I got a lot of stuff on the screen at once here. Every 10 loops, we want to print out checkpoint and the loop number. So how do we do this? We can check if a loop is on the 10th loop, if the modulus with 10 is 0. Okay, so what you'll notice is if we have 10, 20, 30, 40, every time that we're at one of these multiples, if we divide it by 10, the remainder is 0, which means this number here, modulus 10, is 0 on the even multiples of 10. If you wanted to cheat a little bit, you could technically increase I by 10 every single time. However, we're going to do the longer way just so that we can learn a little bit more. So I'm going to say if I mod 10 is exactly equal to 0, which means that we're on an evenly divisible 10th multiple, so 10, 20, 30, 40, etc. Then we want to console.log, and I'm going to use a template string here, which is what we learned in the while loop video, which is the kind of angled backticks, which is right above the tab symbol. And I'm going to log out checkpoint as a string, and I can interpolate a variable into the string using $sign and curly brackets, just like this. So in this case, I'm going to put the I variable inside the string. So this is going to be 10, 20, 30, 40, etc. Okay, so just to look what that looks like, I'm going to save that file, and I'm going to run node problem set 3. And you can see that we indeed get kind of almost the answer that we need, right? Checkpoint 10, 20, 30, 40, but we do get checkpoint 50, 67, 80, 90, and then checkpoint 100. So we actually don't want these two, 50 and 100. Okay, so this is kind of the tricky part, which is step 3 and 4. How do we make it so that when we're at 50, we don't enter this? There are a few ways to do this. We can expand this if statement conditional to do a more complicated check that's also checking if you're not 50 and if you're not 100. However, I'm just going to simplify this by doing a continue keyword. So I'm going to say if I is exactly equal to 50, what I want to do then is I want to make sure that I don't execute the rest of this code. So the keyword for that is continue. But before I continue, I want to print out this message there, halfway there, which is the one I was asked to print out. So I'm going to console.log and then put halfway there. Okay. So what this is saying is on the 50th loop, when I is 50, we're going to enter this conditional, and the order of this does matter. Notice I put it above this conditional, which I'll mention in a second why that's important. But on loop 50, we're going to enter here, and we're going to log out halfway there, and then continue is going to bump us right up to the updater, which is I here, and we're going to increase I by 1, and then the next loop is going to be 51, and we're going to skip this and continue with our checks. Okay. Unlike the while loop example where we also had to do like the I++ over here, it's easier with a for loop in this case since this is done inherently in this updater already for us every single iteration. Okay, we can actually use this same idea for 100, but before we do that, let's see if this actually works. So I'm going to clear this out and I'm going to rerun that, and we can see that awesome, right? We have 10, 20, 30, 40, then we have halfway there, but we don't have 50, right? So that's the key here. That's this right here. We want 40, but we don't want 50, but we want 60. We're still getting 100, which we're going to fix next, but it's going to be the same method. So then for 100, we can say if I is exactly equal to 100, then we want to console.log. And in this case, we're going to console log the you made it string. And we can also, again, continue right after. Okay, and this is almost our answer. We just need to put the all done at the very end, but you can see that the 100 is no longer being printed out because we're entering here and we're continuing right up to the next iteration, which is actually going to break us out of the for loop because that's going to be 101. Okay, so I'm going to add the console log all done here at the end, just to really finalize this, and you can see that that's the final answer right there, and that should match what we have. But the one thing I wanted to mention was, why does it matter where we put these, right? If we put these after the checkpoint, let's see what actually happens. Okay. Didn't get a chance to do this in the while video since that was a bit long, so I saved it for this video. But if I run this, we'll see that we get checkpoint 10, 20, 30, 40. We still get checkpoint 50. Then we get halfway there, which seems like it's working. Then we go 60, 70, 80, 90, but then we get 100, and then you made it, right? So if you run through this, you can see why that is, right? Because we're actually checking this, which is true first, and then we're going over to the checks after. So we're always pretty much going to run this on the 50 and 100 case, unlike before, where if I undo this to see what we had before, we have this continuing to the next loop and actually skipping all of this. In the case of 50, we have this continuing to 101 and actually skipping this in the case of 100. So we don't actually get that repeat number, which is what we were trying to avoid. Okay, perfect. So I know that was a lot. I hope that was useful for you. Going through these exercises really helps cement this idea. If you didn't get a chance to go through the while loop videos and the while loop exercises, I really encourage you to go through those so you can really get an understanding of looping in general in JavaScript, because these are the two fundamental ways to do loops, and all the other loop types that we'll learn in the future are actually kind of based on this premise. So in the next video, we're going to go over one of my favorite topics, which is functions. It's going to be quite a deep topic. I got quite a lot to go through there, but I'm super excited about that. If you found this video helpful, please like the video and subscribe to the channel. I'd love to hear in the comments any other solutions that you came up with for this problem set exercise, as well as just anything in general that you've seen so far with while loops or for loops that hasn't made sense. I encourage you to post it in the comments and I'll get back to you. That said, I'll see you in the functions video. See you later.